A few months ago, I purchased an Arriflex 16BL camera from eBay. These cameras were produced in the 1960s and 70s as the first silent, self-blimped 16mm film camera from Arri. As you can see, it's quite a beast, requiring a sound blimp over the lens to keep it quiet. Thousands of these cameras were produced, eventually being replaced by the Arriflex 16SR in the mid-1970s. The 16BL was based on the same reliable technology that made the Arri 16S and 16M filmmaking workhorses of their day. Since I had to take it apart to clean and lubricate, I thought it might be interesting to look inside the ingenious design features of this first-generation 16mm sound camera. I've already given it a once-over, cleaning out countless film fragments and dirt, and relubricating mechanical components with Arri grease. Once the camera is disassembled, you can see that the entire camera movement exists on a single block of metal. The key to making this camera quiet is the fact that this movement sits inside a metal outer casing and is suspended within the casing on these rubber bumpers. Theoretically, any sound generated by the film movement would be considerably dampened by the time it reached the outer shell. Let's take a closer look at the film movement. There's a film gate and pressure pad, virtually identical to the 16S and 16M, a tachometer and film footage counter, and the rotating mirror shutter made famous by Arri. Here's the Arri bayonet and standard lens mount. As you can see, it's solidly attached to the film gate mechanism, so the flange distance of the lens to film won't change. As I did here, you can pull out the whole film movement and not have to worry about changing the lens or ground glass depth settings. As a result, this camera is very reliable, unless it's been monkeyed with. Here, you can see the mirror shutter moving across the film plane, alternately exposing the film and projecting an exact image of what's being photographed onto the ground glass for framing. Let's look at a couple of other things while we have the movement naked, so to speak. Here's the film gate. The claw at the bottom slides the film forward to the next frame. There's a registration pin at the lower corner of the gate that pushes out when the film is moving, then locks in when the film is stationary and being exposed to light. This pin holds the film, or registers it, in place, resulting in an extremely steady film image. Remember, this happens 24 times a second for most shooting. You can't see it too well, but there's also a side spring-loaded pressure pad that keeps the film in line side to side as well. When you close the film gate, a pressure pad behind the film also keeps it steady in place. Again, here's the tachometer. There's a red line for showing 24 frames per second when the camera is running. The footage counter is below. The 16BL had either feet or meters indicators. Rubber isolation bumpers support the movement inside the camera body. Here's another rubber mount at the back of the movement. Nothing in this film movement depends on springs. Each pin, as it engages the film, is controlled by positive driven motion by ultra-precise cams. Any part subject to wear was made of hardened steel to ensure long life. The camera outside shell is equipped with a couple electronic connectors. The electronics could be easily removed from the back of the camera for repair or updating. The hole in this side is for the motor that drives everything. And this is the front, where the lens mount and blimp attachment goes. These two holes on the bottom are for the two rubber sound isolators. By removing the rubber mounts, you can then remove the whole camera movement. Here's the film movement reinstalled into the outer casing. It's still loose as I only have one screw attached to the rubber mount on the side. The inching knob has a spring and rubber connector so that you need to push it down and turn in order to rotate the film movement when loading or checking the gate. When you're not pushing down, the knob actually doesn't touch any of the film gearing, eliminating any noise that would transmit to the outside. Sometimes this knob assembly works loose, so I use Loctite and nail polish on the bolts inside. Now to put the rubber bumpers back in place. These covers protect the openings and further position the rubber mounts. This front plate fits over the mount and supports the lens blimp. The lens blimp was a necessary evil, as many photographers hated this soundproof enclosure around the lens. You could use the camera without a lens blimp, but all the noise from the film movement would transmit out the front of the camera, since the lens mount was directly attached to it. Once you attached a proper size lens blimp, and there was quite a selection for different lenses, the camera would achieve its quiet operation. This worked because the lens blimp was attached to the outside camera casing, insulated from the actual film movement. A thick, sound-absorbing glass was required up front, and the outside lens controls only touched the actual lens through rubber sound-absorbing mounts inside the blimp. Using a zoom lens all the time wasn't that bad, since the lens and blimp came off and on together. Prime lenses were more challenging, as the lens had to be carefully fitted to the sound-isolating connections inside the blimp. The Arri 35BL1 and 2 used a similar system with a lens blimp. With the introduction of the 35BL3, Arri started using a special sound-absorbing lens mount, so the lens blimp was no longer required. The 16BL had a couple of different motors during its production. Early motors did not have built-in crystal sync control, meaning that the sound recorder had to use a pilot tone signal generated by the camera and recorded by the sound recorder in order to sync audio. Later motors had crystal sync devices in them that ran the motor at a very precise speed, so that a pilot tone signal wasn't necessary. The motor had special gears that were required for either 24 or 25 frames per second operation. The gears could be swapped out and the motor replaced. The motor itself attaches directly to the film movement with 3 screws inside the film chamber, and an outside covering prevents sound from leaking out. The start-stop handle is attached to 3 wire connectors underneath. This is a late model 16BL with a built-in light meter. I took it out, cleaned all the optics, then reassembled the door. The meter has split optics that divert some light to it through the door. These 2 contacts supply power to the light meter when the door is closed. The electronics module can be reinstalled pretty simply with 4 screws. The 16BL requires 12 volts for operation. You'll notice that even when fully assembled, there's still a big gaping hole where the film magazine needs to go. I took this one apart because it was rusted and really scuffed. I repainted it with VHT black crinkle paint, and I think it matches pretty well with the original Arri paint. A lot of the screws and metal parts were rusty, so I dropped them into vinegar for a day or so. There's a couple of tricky things about the magazines that can ruin the quiet running of the camera. First, you can only use 16BL mags on the 16BL camera. These have straight gears at the bottom, whereas 16M mags have slanted gears, so they're not interchangeable. Also, the 16BL mags have these funky turn knobs on the back. They're made so that you need to push them in to engage the spindles when loading. Again, this means no contact, and therefore no sound escaping from the spindles when running. Most important for sound, the entire guts of the magazine is separated from the outside shell by a rubber gasket. In many 16BL magazines, this gasket has dried out, becoming brittle and solid with age. This means the magazine will transmit a certain amount of sound to the outside shell. Likewise, there's rubber gaskets and light seals on the bottom that also can dry out and crack. This magazine, though scuffed and rusty, still had good sound gaskets, meaning they were still rubbery and not brittle. I put a new light gasket cut from black foam into the bottom. After I cleaned everything, lubricated, and reassembled it, this magazine was amazingly quiet. The camera is now ready to go. There's a crystal sync accessory controller which allows the motor to run at exactly 24 frames per second. There were several third-party accessories and motors that updated the electronics to more modern standards. Although these cameras average 50 years old, many are still in good running condition, at least mechanically. They are relatively cheap to obtain and may require a good cleaning and lubrication to run properly. Unfortunately, they're almost impossible to convert to Super 16 because of the mirror shutter coverage and placement. If you need a widescreen image, I'd suggest cropping in the regular 16 frame instead. After all, it should be as steady and sharp as possible, considering the elaborate engineering, design, and machining that produced these classic cameras. If you like this video, please subscribe and hit like. I appreciate comments and suggestions as well.